What is the law of definite composition? The law of definite composition was proposed by Joseph Proust based on his observations on the composition of chemical compounds. Proust proposed that a compound is always composed of the same proportions of elements by mass. Though initially controversial, the law of definite composition was supported by Dalton's atomic theory. Who is Joseph Proust? Joseph Louis Proust, also known as Louis Proust. He is a French chemist who proved that the relative quantities of any given pure chemical compound's constituent elements remain invariant, regardless of the compound's source. This is known as Proust's law or the law of definite proportion, and it is the fundamental principle of analytical chemistry. Proust also carried out important research in metallurgy, explosives, and nutritional chemistry. Law of definite composition or law of definite proportions. To simply put, a particular compound is always made up of the same elements in the same proportions no matter what its source is. The proportions can be found by calculating the percent by mass. For example, CO2. CO2 is always composed of one atom of carbon and two atoms of oxygen. The proportions can be found by calculating the percent by mass. Percent mass of element is equal to mass of element over the total mass of compound times 100. Example problem in law of definite composition. CO2 is always made up of one atom of carbon and two atoms of oxygen. The ratio of O to C in carbon dioxide is always 32:12 or 2.66:1. 10 grams of carbon dioxide gives 2.73 grams of carbon and 7.27 grams of oxygen gas. Also, 30 grams of carbon dioxide produces 8.19 grams of carbon and 21.81 grams of oxygen. How does it show the law of definite composition? Let's find out. Solving using the percent by mass formula. Remember, percent mass of element is equal to mass of element over the total mass of compound times 100. In compound 1, here are the given. 2.73 grams of carbon, 7.27 grams of oxygen, and 10 grams, which is the total mass. 2.73 grams of carbon, which is the mass of element, over the total mass of compound, which is 10 grams, times 100%, which gives us 27.3% carbon. To know the other percent mass of element, which is oxygen, we have to subtract 27.3 to 100, which gives us 72.7% oxygen. In compound 2, here are the given. 8.19 grams of carbon, 21.81 grams of oxygen, and 30 grams, which is the total mass. Substituting the value, we get 8.19 grams, which is the mass of element, over the total mass, that is 30 grams, times 100%, which gives us 27.3%. To know the other percent mass of element, which is oxygen, we have to subtract 27.3% to 100, which also gives us 72.7% oxygen. It shows that no matter what the amount of the mass of the compounds, the proportions of the elements in that compound will always be the same. CO2 or carbon dioxide will always be composed of 27.3% of carbon and 72.7% of oxygen. Another example. Suppose that 120 grams of salt or NaCl is broken into sodium and chlorine. We obtain 47.33 grams of sodium and 72.90 grams of chlorine. Find the ratio by mass of sodium to chlorine. So, we have to divide 47.33 grams, which is the mass of element, over the total mass, which is 120 grams, times 100%, we would get 39.44. The other element, we have a mass of 72.90 grams over the total mass, which is 120 grams, times 100%, which gives us 60.56 chlorine, or 60.56% chlorine. Finding the ratio by mass. To find the ratio by mass, we have to divide the smallest number by itself, which gives us 1, and the highest number, which is 60.56, by the smallest number, which is 39.44, which gives us 1.54. The Na to Cl, or the sodium to chlorine ratio of these masses, is 39.44 over 60.56, or 1 is to 1.54. This ratio never changes. 1 is to 1.54. This means that for every 1 gram of sodium, there is 1.54 grams of chlorine. And this ratio never changes. It is definite. Another example. If you could take 100 grams of water, or H2O, and break it down to its elements, you would obtain 11.19 grams of hydrogen and 88.81 grams of oxygen. In every sample water, the H2O ratio, or the hydrogen to oxygen ratio of these masses, is 11.19 over 88.1, or 1 is to 8. This ratio never changes. Dalton postulated that atoms combine in simple whole number ratio. If the ratio of atoms of each element in a compound is fixed, then it follows that the ratio of their masses is also fixed. Let's apply what we have learned. A 20-gram sample of sucrose contains 8.4 grams of carbon. What is the mass percentage of carbon in sucrose? Using the percent by mass formula, we have to divide 8.4 grams of carbon, which is the mass of element, over the total mass, which is 20 grams, times 100%, which gives us 42% carbon. 42% is the mass percentage of carbon in sucrose. Another problem, sucrose is 51.50% oxygen. How many grams of oxygen are in 20 grams of sucrose? To solve this problem, we have to multiply 51.50% by 20 grams, which is the total mass. This gives us 10.30 grams of oxygen. There are 10.30 grams of oxygen in 20 grams of sucrose. Last problem. Two unknown compounds are tested. Compound 1 contains 20 grams of nitrogen and 100 grams of hydrogen. Compound 2 contains 4 grams of nitrogen and 20 grams of hydrogen. Are the compounds the same? Let's find out. 20 grams of nitrogen, which is the mass of element, over the total mass, which is 20 plus 100, which gives us 120, times 100%, we would get 16.7% nitrogen. To know the percent mass of oxygen, we have to subtract 16.7 to 100, which gives us 83.3% hydrogen. In compound 2, we have to divide 4 grams of nitrogen, which is mass of element, over the total mass, which is 4 plus 20, 24 grams, times 100%, which gives us 16.7 nitrogen. To know the percent mass of hydrogen, we have to subtract 16.7 to 100, which gives us 83.3% hydrogen. Evaluating the value of compound 1, we have percent mass of nitrogen, which is 16.7%, and percent mass of hydrogen, which is 83.3%. And in compound 2, we have percent mass of nitrogen, which is 16.7%, and in hydrogen, 83.3%. As we can see, compound 1 and compound 2 have the same composition. Therefore, we can say that the compounds are the same. That ends my discussion. Goodbye, stay safe, and God bless.